For lesson 96, we're going to talk about functions, and we're also going to talk about graphing those functions. We know that the surface area of a rectangular prism is the sum of the area of its sides. A cube is a special rectangular prism with 6 square faces. If we know the area of one side of a cube, we can find the surface area of that cube. We can only make a table, or we can make a table to show the surface areas of cubes based on the area of one side of the cube. So if the area of one side of the cube is 4, surface area of the cube is going to be 24, because we can multiply by 6. 9, 54, 16 times 6, 96, so on and so forth. Now, won't the square root of each number in the first column produce the length of each edge of the cube? And the square root of 4 isn't each side's length 2? It should be, because remember, cube, all sides are the same. In the area of one face, we're going to take side times side, and that number has to be the same. Okay? So something to think about there. Now, it says use the data in the table to help you create a formula for the surface area of a cube. Let A be the area of each side of the cube, and S be the surface area of the cube. So capital S is going to be our surface area. Okay, so we have capital S equals 6A. So the surface area is going to equal 6 times the area of one face. Okay? So your formula is an example of a function. A function is a rule for using one number. Okay, input. In this function, side area is the input and surface area is the output. Because the surface area of a cube depends on the area of each side, we say that the surface area of a cube is a function of the area of a side. If we know the area of one side of a cube, we can apply the function's rule or the formula to find the surface area of a cube. So the numbers in the first column we're going to put in to the formula, and the numbers in the second column is what comes out of the formula. So in, first column's in, second column's out. So example 1 says find the rule for this function, then use the rule to find the value of m when L is 7. So remember that the rule for a function must be true for every number pair in the function table. So just because the rule works for one doesn't mean it's going to work for the other. So if we look at the 5 for the L, this top number, if we look there, okay, I think 5 times 4 is 20. Okay. Well, we can't do 7, but let's look at 10. Is 10 times 4 25? No, so we can't use that multiplication. Well, let's look at addition. 5 plus 15 is 20. So 10 plus 15 is 25. 15 plus 15 is 30. That works. Okay. So the rule is going to be plus 15. Okay. And then to find m when L is 7, we do 7 plus 15, which is going to equal 22. Okay. So my rule is plus 15. I need to have that, and my answer for that missing m number is going to be 22. It says find the missing number in this function table. So when x is 2, 3x minus 2 is 4. When x is 3, comes out as 7. When x is 4, we're looking for what comes out from the formula. So our formula is 3x minus 2. Okay, I'm going to plug 4 in for x. So all I'm going to do is put 4 in for this x. So 3 times 4 minus 2. 3 times 4 is 12. Minus 2 is 10. So my answer is 10. So all they're doing is putting this number for x in for x. So for 2 they did 3 times 2 is 6, minus 2 is 4. 3 times 3 is 9, minus 2 is 7. 3 times 4 is 12, minus 2 is 10. Many functions can be graphed on a coordinate plane. Here we show a function table that relates the perimeter of a square to the length of one of its sides. On the coordinate plane, we have graphed the number of pairs that appear in the table. The coordinate plane's horizontal axis shows the length of a side, vertical axis shows the perimeter. So when we're graphing functions, remember this help you. Okay, you have to crawl before you climb. Meaning we're going to go along the x-axis, the horizontal axis, kind of like the floor. We have to crawl, and then we're going to climb. Kind of like when you're growing up. You have to crawl first before you can learn how to climb. For each number pair of the function, the first column gives the value along the horizontal, second along vertical. So to graph the first number pair from the function table, you have to crawl 1 before you climb 4. For the second, crawl 2 before you climb 8. So to graph it, we're going to crawl 1, climb to 4. For the second one, we'll crawl 2, climb to 8. 3, 12, 4, 16. Okay. Now, this should make, if I connect the dots, I need to keep going, it should make a straight line. If it doesn't make a straight line, you did something wrong. Okay. So if I use my line tool, I can make it a perfectly straight line. But these functions, they should come out as a straight line. We've used 2 different scales on the 2 axes so the graph is not too steep. Okay, if I had used 1, 2, 3, 4, 5, 6, I would have had to make a huge scale. It would have been really long. It would have been really steep. We would have went kind of something like this if we would have did that. Okay? The graph points show the side lengths and perimeter of 4 squares with side lengths of 1, 2, 3, and 4 units. Notice that the graph points are aligned. So I'll regraph these just so you can see. Okay, they come out in a line. Of course, we can graph many more points and represent squares with side lengths of 100 units or more. We can also graph points for squares with side lengths of 1/100th or less. In fact, we can graph points for any side length whatsoever. Such a graph would look like a ray. It would fall somewhere on this ray. Notice I add 1 arrow. Okay? It would fall somewhere on that ray, no matter what. So the perimeter of an equilateral triangle is a function of the length of its sides. It says make a table for this function using side lengths 1, 2, 3, and 4. Then graph the ordered pairs on a coordinate plane. Send a ray through the points to represent the function for all equilateral triangles. So we're going to start with our table. Side lengths perimeter 1, 2, 3, 4. Okay. But equilateral triangle mean all the sides are the same. So remember, if all the sides are the same, we could just take our side times 3, and that's going to equal our perimeter. Okay, so 1 times 3 is 3, 2 times 3 is 6, 9, 12. So there's our table. Now, missed my cord. So I'll just have to make one here. We have 1, 2, 3, 4. 1, 2. Okay, I just numbered the numbers I'm going to use, make it quicker here. So I'm going to graph all these points from my table, and starting at my origin, I should be able to draw a ray that goes right through all of those points. Okay, and that represents the function for all equilateral triangles. Okay, so go ahead, do the practice set, make sure you bring any questions you may have to class. Okay. There's a graph on this last page to help you if need be.